Welcome to Lesson 6 of Module 1 on Data Warehouse Concepts and Architectures. I'm going to start with a question about data warehouse folklore. What is the real story behind the legend of beer and diapers? Lesson 6 continues with informational background about data warehouse development from Lesson 5. Lesson 6 presents business aspects of data warehouses in retail and education, key industries for data warehouse deployment. These examples depict architecture and maturity concepts from Lesson 5 and provide a context for skills learned in later modules. You have 3 learning objectives in this lesson today. You should be able to discuss requirements for data warehouses in large retail firms in K-12 education. Using the background from Lessons 4 and 5, you should reflect on the maturity of data warehouse development in retail and K-12 education. The retail industry pioneered data warehouse usage. Walmart first deployed a data warehouse in 1990 to support decision-making about historical sales data. The retail industry now has decades of experience with data warehouse usage to support vital decision-making about store site selection, product mix, supply chain management, product pricing, and vendor management. As recognition of demand in the retail industry, major DBMS vendors such as Oracle, IBM, and Teradata provide customized data warehouse solutions for the retail industry. To depict details of data warehouse usage in the retail industry, this lesson covers business requirements for the TPC-DS benchmark, a major data warehousing benchmark developed by the Transaction Processing Performance Council, or the TPC. The nonprofit TPC develops benchmarks for transaction processing and business intelligence processing, with input from a wide base of contributors in industry and professional associations. The TPC-DS benchmark represents business intelligence requirements of a retail firm offering products in geographically distributed stores, online through web shopping, and printed catalogs. To support these requirements, the TPC-DS benchmark involves transformation of data sources and query execution to support business analyst and decision-making tasks. 3 major data sources, store, web, and catalog, provide transaction data about retail sales in physical stores, online, and printed catalogs. 2 secondary data sources, inventory and promotions, provide details about inventory levels and promotion offerings. The data integration process transforms and integrates these data sources and loads them into the data warehouse. The data warehouse supports ad hoc queries, repetitive reports, iterative queries showing relationships and trends, and queries supporting data mining analysis. The data warehouse in the TPC-DS benchmark maintains data about important business entities and historical facts related to sales, inventory maintenance, promotions, and customer profiles. This diagram provides a simplified representation of major types of business entities and historical facts in the TPC-DS data warehouse. For the most important business entity, customer, the data warehouse maintains contact details, addresses, and household buying demographics. For historical facts, the data warehouse maintains product sales and returns in each channel, store, web, and catalog, along with inventory levels. For each major type of historical fact, the data warehouse maintains many quantitative variables, not just basic values, for the level of sales, returns, and inventory. Learning standards substantially influence compulsory K-12 education in many countries. In the USA, the federal government and state governments impose standards and regulations on local school districts. School districts in USA states operate autonomously with locally elected school boards setting policies and rules. Learning standards require local school districts to report on student performance to facilitate comparison of school districts, improve learning outcomes, and foster innovation in instruction. Individual USA states often impose reporting requirements, while the federal government requires reporting for grant eligibility. Independent school districts cooperate in a federated manner to provide a data warehouse solution to satisfy reporting requirements. Colorado and other states have invested in data warehouses to support assessment of student growth. In 1997, the Colorado legislature passed a law that required development of accountability systems for K-12 education. The Colorado legislature extended this law in 2004 and 2007 to measure student growth, not just student achievement at a point in time. In response to the accountability laws, the first data warehouse was developed beginning in 2002. The Student Growth Extension, performed from 2007 to 2009, had a budget of about $6.7 million. Because of development since 2002, the Colorado Education Data Warehouse is in a mature state with data governance policies, processing and standards to manage the flow of data from capture to use. The Colorado Department of Education embarked on two major projects in 2013 to add data from preschool and improve transfer of data from school districts to the data warehouse. The primary data sources for the Colorado Education Data Warehouse are standardized achievement test scores. Students take standardized tests once per year in the second half of the school year. School districts provide data for student grades and demographic attributes. Colorado has 178 school districts, so the number of data sources provided by school districts is large. This diagram shows other data sources provided by higher education, public safety, corrections, early childhood development, and human services. Colorado School View is a public portal that uses the Education Data Warehouse. School View supports visual analysis of student growth on achievement tests for all Colorado school districts. Users can compare median student growth in reading, writing, and math by school as depicted in this snapshot. In addition, users can search by student group, grade, and ethnicity, as well as rolling up to school districts. The public part of School View serves parents and the public. Educators and government agencies have access to the private part of School View. The Education Data Warehouse maintains data about important education entities and historical facts related to standardized test scores and student growth in testing performance. This diagram provides a simplified representation of major types of education entities and historical facts in the Education Data Warehouse. For student demographics, the Education Data Warehouse maintains gender, ethnicity, location characteristics, and language spoken. For accommodations, the Education Data Warehouse maintains status of disability, English proficiency, and homelessness. For standardized test results, the Education Data Warehouse maintains 4 variables. This lesson provided prominent examples of data warehouses in retail and education to provide a context for material covered in other lessons of this module. You learned about characteristics of business drivers, data sources, and business entities, and data warehouses for retail and K-12 education. Large firms, such as Walmart, with distributed stores and multiple sales channels, have driven development of retail data warehouses. Federated education data warehouses in the USA have been driven by standards imposed by higher levels of government on highly decentralized school districts. Data warehouses in retail and education have a high level of maturity with development over decades. In answer to the opening question, the diaper beer legend occupies a special place in data warehouse folklore. According to the legend, a large retailer noticed an unexpected correlation using a data warehouse. The correlation indicated strong sales of beer and diapers together on Friday evenings between 5 and 7 p.m. According to the legend, the retailer reorganized product placement, putting beer and diapers together near store exits to realize substantial increases in sales on Friday evenings. Hundreds of articles have cited this legend as evidence of business value from data warehouses. The legend contains a nugget of truth. Thomas Blischak, as part of a study of Osco drugs, found this correlation in 1992. However, Osco drugs did not change product placement because of the correlation and reported no sales increase. The legend spread because of overzealous reporting of a speech given by Thomas Blischak.